Hey, calculus people. Quick answer key video here for part two. Figured I'd do it for part two because it's more representative kind of what's going to be on the test. So if you do well on this, you'll be, doing great. I do want to say ahead of time, there's sometimes more than one way to do a problem. And you may be correct even with a different way of doing it. Let's start off with this one. Here's a limit definition derivative, which we practiced last time I saw you. And we're going to do this. Limit as delta x approaches 0 of, and then I'm going to do this thing with an x plus delta x plugged in everywhere you see an x. It's going to get pretty big. 1 plus x plus delta x right there, minus 2 times x plus delta x squared. I bet a lot of you forgot how to do this part. Because we didn't do one of those in class, but good thing we got this review here. All right, so we got this. Second thing is when you do regular f of x, which is right here, make sure you do a minus sign and parentheses around the whole thing. All right, so now it's a bunch of foiling, right? So I'm going to focus just on this. I'll take that negative sign into each. Notice I'm rewriting the limit every time because that's what professionals do, right? I don't need parentheses here because there's nothing to distribute. This one, I'm going to wait to distribute that until I actually do this squaring. Remember, it's x squared plus 2x delta x squared. Then this is minus 1 minus x plus 2x squared. So we're almost there. Now I can take that negative 2 into each one of those. And then I will be right where I need to be. I'm going to write it up here because I'm running out of room over there. So a little arrow. We got limit as delta x approaches 0. And then we still have the 1 plus x plus delta x. Now we have minus 2x squared. We have minus 4x delta x. And we have minus 2 delta x squareds. And then I still have these, minus 1 minus x plus 2x squared, all over delta x. All right, now is when stuff starts canceling. You can see in that closely, we got a 1 and a negative 1. We got an x and a negative x. We got a negative 2x squared and a 2x squared. Awesome. What's left over? Let's see. We have a delta x. We have minus 4x delta x. We have minus 2 delta x squareds, all over delta x. So remember, you can cross out one of each. I can say, okay, this bottom can cancel with one of those, and one of those. Make sure you don't forget to put a 1 there. A lot of rookies would forget that. But that's really delta x over delta x, which is worth 1. So in the end, it becomes 1 minus 4x minus 2 delta x. And now you can finally plug a 0 in for delta x, not for x. So 1 minus 4x. Okay, that's your end answer. Does that match what you would have done with a shortcut? Yep, 1 minus 4x. Awesome, just a lot longer. Remember, it's like hiking. Enjoy the hike. All right, so I'm going to pause, do these easy ones first, and then get to the harder ones. Okay, so pretty straightforward. This one you could have cubed it out if you wanted, and then gotten it. But it says first step only, just like your test will. So if I do ninja rule, really easy. Then this one, make sure you rewrite it before you do your derivative rules. All right, now to the interesting stuff. These are that was power rule, chain rule. This one's going to be a product rule. Just remember, you got u prime v, so we're going to do u prime is 3x squared minus 1. That's u prime. And then v, you just write it as normal. Okay, and then plus v, so there's u prime v, v prime u. What's v prime going to be? Negative 2x to the negative 3. Make sure you don't rookie that one up. This one's negative 6x to the negative 4. That's v prime. And then u is over here, and you just copy it down. All right, and then we got a quotient rule here, so that was a product rule. Now for a quotient rule, here's the high, here's the low. Okay, so you got low, so low, you just copy it. D high, derivative of the high is just 3, right? Minus high, D low, 2x plus 5 over low low. There you go. Easy, right? First step derivatives are easy. Okay, so now we get to this one. This is a little trickier because you got to rewrite some stuff. First of all, a cube root of x is normally x to the 1/3. So if it's in the bottom, that's actually x to the negative 1/3. The negative is what makes it go to the bottom. So this, I was just checking if you had basic exponent skills, which, you know, sometimes are tough for people. Here's another exponent rule. I'm checking all the exponent rules. This one was a negative 1/3. This one, you had to notice when you multiply two, you add their powers. So what's 1 plus a half? Don't write 1 1/2, write 3/2. It's the cool thing to do. Notice I wrote y because I haven't taken the derivative yet. After you get it written nicely, you know, you just do your normal power rule. So we got negative 1/3 x to the negative 4/3 because I'm taking away 1, which is 3/3. All right, then we get to more interesting stuff. This one is a product with two ninjas. Okay, so I got a u and a v. It still looks like a product to me, but when I do u prime, I'm going to do ninja rule. When I do v prime, I'm going to do ninja rule. So it's just like what we did above, just a little crazier. So here's u prime. 3 times this thing to the second, and then here's your ninja. Derivative of what was inside is 12x. Okay, that's all u prime. Now v I just write normally. Just x cubed minus 7 to the 4th. Plus, I'll probably be able to fit it in. Now I'm going to go v prime. So I'm going to go 4 times this thing to the 3rd times the derivative of what was inside, which is just 3x squared. And then u. We just copy u down. All right, that's it. Awesome. Cruising, man, cruising. Okay, so here's another combo problem. This is, overall, it's a ninja because it looks like something in a third power, but it has a quotient inside. Okay, but you just treat it like the ninja rule at first. Okay, ninja rule says 3 times this thing to the second. Now the ninja part times the derivative of what was inside. Oh, now it gets bigger. Okay, so we got to low d high this thing. Here's high, here's low. Right. Low d high, derivative of the high is just 1, minus high d low, which is also just 1, over low low. Not bad, not bad. Right? It's still just a ninja with a quotient. Right back here. This one's a quotient with a ninja. Ooh. So this one switched it up on you from the last one. So I treat it like a quotient rule because it looks like a fraction. It just happens to have something ugly in the bottom. So when I do this, here's my high, here's my low. When I do this, I got low. Remember, you're not taking the derivative right now. Times derivative of the high which is 5, minus high d low. Here's where it's weird, because when you go to take the derivative of low, you have to do a ninja rule on it. It's not exactly hard, and you gotta resist the urge to take the derivative too early. Okay, you write it the first time just like you see it. All over low. 3x plus 2, instead of writing to the third to the second, you could just multiply the powers. Once again, exponent rules. Alright, let's check the other page. Sorry to all the trees out there. I'm offended by killing one of your friends. Here's one of the things we used to do. Find the equation of a tangent line, so I need a slope and a point. Well, I got a point. I just need the slope. How do you find the slope? Instantaneous slope is the derivative of this guy. So if I plug in this point, the x part, right, I'm going to have 6 times 1 minus 6, which means my slope is 0. So if I have my normal y equals mx plus b, and my slope is 0, and my y is negative 1, right, I'm just using the x part and the y part. B is negative 1, so y equals negative 1. It's just a horizontal line through negative 1, 1. That was weird. Usually you can get it in slope-intercept form by using a point and a slope. Alright, now we get this thing. You threw a corn dog off a roof of a 120-foot building after realizing it was vegan and not the usual assortment of random animal parts. To be fair, it's called a corn dog, so vegetarians shouldn't be shocking. If you launch it upward at a rate of 18 feet per second, when will it hit the ground? Before I even get going, I need to have my 3 equations. Remember, negative 16t squared is for gravity, feet per second, and I'm going to put plus 18t, and then it said we were on a 120-foot building. It's plus because I threw it upward. If I would have thrown this hot dog downward at 18, it would have been a minus. So you got your initial velocity here, your initial height here, and then I go ahead and take the derivative and go ahead and take the derivative of that. Not that we usually use this, but it's the pull of gravity in feet per second squared. When will it hit ground? Classic question. You set the height equal to 0. I'll pause and come back once it's done. Alright, so I got 2 answers when I did the quadratic formula. Remember your A, B, C. You got this crazy formula. It gave me 2 answers. Only one of them makes sense. It doesn't make sense to have a negative time. So I say it takes 3.36 seconds to hit the ground. Remember, word problems deserve word answers. Max height is another classic question. This is a 2-step question because first, you can find when it gets to its max height by setting velocity equals 0. Because we're talking about its upward velocity. And this is a much easier equation to solve. We just have to do 32 or 18 divided by 32. So the hot dog reaches its peak height at 0.5625 seconds. Okay, you got to plug that in to find out how high it is. So I'll do that. I'll pause and do that. So yeah, part 2 of a maximum height question is take the time when it hits its peak height and you plug it into your height function for t. So there it is, plug, 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 hit equals, and you get the height equals 125.06 feet. So you only threw it 5 feet in the air. You weren't that angry. It's more like tossing it. Alright, and last question, what velocity will the corn dog be moving as it hits the ground? Because we found out when it hits the ground. All we got to do is use the velocity equation at that time. So v of 3.36, I'll pause it and do the work. Okay, I've plugged it in and I got negative 89.52, which means it's falling downward. So all this stuff, expect to be on there. I also said expect one simplify completely derivative question. Alright, that's the time I have. Smash that like button. Please subscribe and hit that notifications bell so I can bring more of this content to you.